Hello and welcome. This is Organic Chemistry 2 Review 2A.2, and it's presented to you by Science Visualized. Next question. The following compounds show single line in their proton NMR spectrum. Arrange them in the expected order of increasing chemical shift values. Remember, chemical shift values, we use delta for that, and it's measured in parts per million, ppm. Now, if you look at the first structure, there is no carbon in this, there's no proton at that position, no proton. So the only protons we have are the carboxylic acid protons. And carboxylic acid protons, chemical shift for that is about 12, I would say 12 to 14 parts per million. Next, we see that we have this proton. The protons on those carbons are in the same chemical environment, and therefore we're only going to have one signal or one peak, one absorption in the proton NMR. And because the hydrogen on that carbon, there are actually two hydrogens, are on the same carbon that has an oxygen, you expect that to show up between 3.5 to 4.5 parts per million. Next, here you have alkene hydrogens. And of course, that alkene is next to oxygen. Typically, you expect alkene hydrogens to be around 5 to about 6.8 ppm. That's different from aromatic hydrogen, which is around 6.8 to 8 ppm. And then the last structure, all those hydrogens, there are two hydrogens on each carbon, all around. They are all in the same chemical environment. Because of that, you're only going to have one signal. And because it's more like an alkane, you expect the chemical shift value to be generally around 1 ppm. So usually they will say around, say, 0.5 to 1.5 ppm. But generally around 1 ppm. So if we're going to arrange this in the increasing chemical shift value order, we see that the lowest chemical shift value closest to 0 is the alkane proton, so that will be number 1. Then the next one is going to be this, number 2, number 3, and that's number 4. The next question is similar, but now we're focused on carbon NMR. And because we focus on carbon NMR, in this case, we're going to have the carboxylic acid carbon and this other carbon. So that's actually two signals, supposed to be a single line. This will have two signals. The carboxylic acid carbon is anything between 160 to 230 parts per million. And then here, carbon connected to oxygen, it's about 55 to 75 ppm. Generally, you expect it close to 70 ppm. And then here you have alkene carbons. And basically that's usually between 114 to 155 ppm. As opposed to aromatic. Aromatic will be between 125 and 155 ppm. And then the last one here is alkane carbons. And that's basically between, I would say, 0 to about 20, but 20 is on the higher end. So I would say 0 to 15 ppm. So if you're going to arrange them in order of the increasing chemical shift value, that will be number 1, and then number 2, number 3, and number 4. We're ignoring that structure. I did not pay attention to that when I was making these questions.